So it is getting recorded and okay, the first question we have solved, and basic idea was concept behind that was that the angle between the weight vector and the decision boundary remains 90 degree. So it will always remain 90 degree. This is the second question where the function fx shown below is approximated using 100 tower functions. What is the minimum number of neurons required to construct the network that approximates the function? So Abhi, can you solve this please?
From what I remember, for one neuron, for one tower function, we need 2 neurons, I think. So if 100 tower functions are there, we need 200 neurons. And then we need a single neuron to like summarize everything. So there will be 2, not 1 neurons.
Okay.
This is the case for 2D, but I'm not sure for 3D and
Okay, so this was 2D only. So this is one, this is one. Okay, this is one, this is one. So for making one tower from here, you need one like this.
right?
I have not revised this concept. Otherwise, I also remember.
From what I remember, I think in the lecture slides in the first 4 weeks, there was a formula that said that such number of neurons are can be sufficient for the functioning and the computation. So I'm just finding it.
Okay, no, that was for something different. This is for the tower function. So there was a class on basically 2D towers and 3D towers. So this is for the tower.
Yes.
And
That
what
was
you
in
were saying,
that was in week 4, right?
Yeah, week 4. Okay, we will revisit this question again. So we go to the next question. So just mark this question again. We will revise this concept. Okay. Consider a sigmoid function is a normal sigmoid function, and here they are saying that W is negative. So if W is negative, then suppose further that we define the steepness of the curve as absolute value of the slope, then select all the correct statements about the function. So here I will just demonstrate with the help of Desmos what happens. You see when the W is not negative, so here what the bias does, initially bias is 0, so here we make bias 1.
Okay.
And if you increase the bias, for example 2, the graph it shifts to the left side. Okay, you can see this.
Yes.
Okay, and this is for a normal, and if you increase W, then the slope increases. Can we see that?
Yes, right.
Yeah.
Yes.
Okay. But when you make W as negative, then it is the reciprocal, vice versa. For example, if we make W as minus, so if it is minus, it means we are decreasing W.
Yeah, the slope smoothens out.
Yeah. So when we decrease, and what happens to the bias? Okay, now bias will go towards like a right side.
Okay.
1 is here, 5 is here. So it starts moving towards right. In normal, okay, it was going towards left, and when W is negative, it goes towards right. So that is the basically concept here. So increasing the value of bias shifts the sigmoid function to the left. That is incorrect. But if W is positive, then this is a correct statement. Then
Understood.
increasing the value of B shifts the sigmoid function to the right. Okay, that we have seen. Increasing the value of W increases that steepness. False. It will happen if W is positive. In case of W, when it is negative, then when we are decreasing, it is increasing the uh, steepness of the slope. Okay. So these are the two. So I'll request everyone, you can use the Desmos and just to get okay, these concepts clear. Becomes very clear okay, with the Desmos.
Yes.
Okay. So next question is, suppose that a neural network has millions of parameters, weights and biases. A team decides to use an optimization algorithm with a learning rate scheme that is local to each parameter in the network. Moreover, the learning rate changes in each iteration such that it should decrease on the steep surface and increase on the gentle surface. Which of the following optimization algorithms satisfy the team's requirements? So, anyone okay, why the ADA is not the answer in this?
Because Adagrad just it divides the nabla by it just keeps dividing the nabla, and the rate of decay of the learning rate is learning parameter is very high, so it will just decrease, it won't increase in the gentle surfaces.
Okay, that's true. So, I hope okay, this is okay, easy. We have studied in quiz 2. So, Adam, and RMS prop, okay, they are the only ones which do that. Here, this is the basically the key sentence which where we have to focus, that it should decrease on the steep surface and increase on the gentle surface. In fact, okay, the best algorithm for this is what, okay, if we recollect, was the Ada delta.
Yes.
Okay. Now we come to this. Suppose we divide the available training samples into mini batches of size 32 to train a model with mini batch gradient descent. Assume that we have 33 different machines to train the model. One out of 33 machines acts as a master machine. The actual weight update happens in the master machine. The master machine can send one sample for the rest of the machines along with a copy of the model in its current state to compute the gradients. We call this entire setup parallelization. Which of the following deep learning architectures can be trained in parallel then? So this basically all the neural networks can be trained in parallel. That is the basically concept. And this question has been repeated in 2 previous year question papers.
Okay.
So basically all the neural networks, including transformers, they can be parallelized.
Excellent.
Then we come to bias and variance. So shall we revise okay, bias and variance? What happens?
Yes, please.
Yes.
Okay. So if we take this, a simple model, it has got like a what? High bias but low variance.
Yes.
Okay. And as we increase the complexity of the model, what happens?
The variance goes high, bias goes low.
The
What?
bias
Wait.
decreases, bias becomes 0, but variance is very high.
Yes.
So with that concept here, now we will solve this question. So we will see one by one. A model with high bias produces high training error and high validation error. That is true.
Yes, it is true.
Okay. A model with high variance produces high training error and low validation error.
False. It's
Okay.
not true.
Because it will have low training error
Yes.
and it will have high validation error.
Yes.
A model with high variance produces low training error and high validation, which we saw here again.
Yes.
Bias and variance can be both made zero if the underlying distribution of the samples are known and also the samples are not corrupted by noise. So that is true.
That is true. Yes.
Okay. So remember, if there is a noise, then bias and variance, they cannot be made zero.
Understood.
But here they are saying it is not corrupted by noise. So here it is clear. Okay. Next question is, all these questions are basically, I think they are checking the concepts only. The calculation part has not come still. Yeah. So next one is, suppose that we use dropout scheme to regularize the deep learning model. Assume that the dropout probability P is equal to 0.75 for all the layers in the model, and the model is trained using a stochastic gradient descent optimizer. Choose the correct statement about dropout regulation. So what is the meaning of dropout? Like if we have got so many neurons,
we can drop some of the samples.
so when we say 0.75, what is the meaning of this?
We are retaining 75% of the basically
Yes,
samples.
yes. So this is the only concept that 0.75 means that out of these total neurons, we will keep 75% of the neurons in one code. For the second one, it will again keep another 75%. And when we do the inference here, what do we do, Ullas, here? So we multiply the weight of each by 0.75
by probability,
by this probability, which is
by this probability given.
yeah. So what it says, dropout reduces 25% of weights from the model during training and inferences. For each iteration, 75% of neurons are dropped. So here, this inference word is incorrect for the first option. What this part is correct up till here. Is it understood by everyone?
Yes.
Yes,
Okay.
yes, clear.
This inference part is incorrect. Otherwise, this is correct till here. For each iteration, 75% are dropped incorrect. Hello. Okay. So we have seen for each iteration, 25% of the neurons will be dropped, and each weight gets multiplied by a factor P during inference. So that we have seen. So this is the concept here. Okay, then we come to 5 marks questions. So these were what correct marks 2. Okay. So this is a 5 marks question. Consider the contours of a loss surface as shown in the figure below. The parameters W1 and W2 were initialized to W1 is equal to -2, W2 is equal to 0. Suppose we run an optimization algorithm, not necessarily gradient based, for a few iterations. The dotted arrows in the figure show the trajectory of updated parameters in each iteration. So when we see the contours, always in the contours, please see the loss. So here you see outermost circle, it is 1.8. Then the loss is decreasing 1.2, 0.8, 0.4. So what can we make out? That the loss surface is in center. I will just take it to the Jamboard. So if we see, the loss function is decreasing here. So this area which is there, this is the area where the loss is decreasing. It is clear how to read the contour map.
Yes.
Yeah, clear.
Yeah, so it's a bowl, basically a bowl shape. So now we see the options. What are the options here? The loss surface is convex with global minimum. So that we have seen, it is a convex and minimum is in this area. the loss value oscillates over iterations. Here we have not seen the loss value is not oscillating. The loss value is decreasing consistently over iterations. So we see here it is decreasing with every iteration. We can see here it is decreasing with every iteration. It is coming down.
Since the loss value is decreasing, and we can say that it is convex, right? Otherwise, it will be concave. Is that inference correct? Like, how do we say it is a convex or a concave one?
Convex because it is a bowl. So if you see a bowl is a convex. But if it is an inverted bowl, then it is concave.
Okay.
How we can draw the inverted bowl, basically?
See here, this is a convex.
Yeah, that thing I understand, but
And
what's the
this is
difference in the figure?
So this is concave. So if you see from here, it is like a hill. I will say this area which is there, you're coming down from a hill. You come
This
down.
loss value is decreasing now.
Yeah. So and again here it has started increasing. So you came down.
And then we climbed up the hill.
0 and now we climbed up. So that's why it is a convex.
Okay, understood.
Makes sense. Yeah.
So this is clear. So this is about basically the concept in this question is that only that you have to read or you have to understand the contours, and these values they will help us in these values which are there. They help us in understanding the contours. Okay, we come to next question. Suppose we have a fully connected neural network with 3 hidden layers containing 10 neurons each. All the neurons in the network use the standard ReLU activation function. Suppose we use cross entropy loss with Adam optimizer with beta 1 is equal to 0.9, beta 2 is equal to 0.99 to update the parameters. The figure below shows the change in the value of one of the weights W in the first hidden layer over the entire training duration. So this also I'll just copy. So what is happening here? We can see that after some iterations, the value of W, what has become? It has become stable.
The value of W has become stable, right?
Yeah. So here it is getting trained, and after some iterations, the number of iterations they have not given, but it has become stable. So this becomes stable when does it become stable? Either we reach the loss, which is minimum. On the loss surface, we are traveling. So either we have reached a loss which is become minimum, and this value can be either 0 or it can be local minimum.
Okay. I mean, we've reached the correct minimum point, so the losses become either 0 or we have reached either one of the local minimums. That is where the loss comes. Makes sense.
So first statement they are saying definitely the loss value at the end of the training is 0. We don't know that. We have just reached the optimum, but we don't know whether it is 0 or it is 2. It can be anything.
Right.
The second, the neuron in the hidden layer might be experiencing a vanishing gradient problem. So this also we understood that if the gradient vanishes, then the W will not update. In the ReLU function, we were taught for the ReLU, if the neurons are zeros, then that the loss does not flow back. And in that case also, some weight vector will not get updated.
Right.
So that condition also applies here.
Okay.
Okay. The loss could have converged to a local minimum after a finite number of iterations that we have seen.
That's seen.
The loss value at the end of the training may not necessarily be zero. So that also we have seen. It might be a local minima, it can be any number.
Right.
Okay. Ullas, anything to add? Okay, Abir here?
No, it's all clear.
Yeah.
It's clear.
Okay. So next we move to next question. Consider a fully connected feed-forward neural network with three hidden layers. The weight matrix W1 connecting the input layer to the first hidden layer is of shape 20 into 150. Similarly, the shape of other weight matrices are as follows: 150 into 100 and 100 into 10. And the weight W4 connecting the final hidden layer in the output layer is of shape 10 into 3. The network solves the multi-class classification problem by using the cross entropy loss function. Moreover, the labels are one, hot, and cold did. So the first question they are asking, how many neurons are there in the network? Every neuron in the network has bias associated with it. So I will encourage everyone, just try to solve a number of neurons.
Yes.
I will also do parallelly here.
No, Lalit sir, they have just asked for the neurons, right?
Yeah.
So we just have to
Yes,
add
yes.
150
Okay.
plus 100 plus 10 plus 3, right?
Yeah, so I was trying to calculate that also. Number of neurons will be this.
Plus
So
3.
this becomes, sorry,
264.
10
No,
also.
10 plus 3.
Yeah,
Not 100, basically. नहीं 100 नहीं आएगा ना बीच वाला
200. अच्छा, sorry.
200 थोड़ी लेंगे now
एक
this is
ये आ गया, एक ये आ गया, एक ये आ गया और एक ये. Now can we calculate the number of parameters also? I think there will be
Yes.
that also. Okay, number of how many parameters including bias? And assume dropout regularization is applied, so that does not mean anything.
It's 120 into 150 plus 150 into 100 plus 100 into 10 plus 10 into 3 plus 263.
So 19263.
Yes.
Yeah, so this will come 15,100. L3 is equal to 100 into 10. 10. I'm just calculating so that all of us we know how to do this. L4 is equal to 10 into 3 plus 3. This is 33. So if we add 3, 1, 4, 5, 9, and 1, 1, 2, 7, 6, 3, 9. Is this the correct answer? 19293?
Yes, it's correct, I think.
Okay.
Yes,
So
correct.
this is correct. So this is clear to everyone again? This again, just I calculated again.
Yeah.
Yes. Yes.
Okay. So now this is the question. Construct a vocabulary V from the foreign text corpus. How much wood could a woodchuck chuck if a woodchuck could chuck wood as much wood as a woodchuck could chuck? It's a tongue twister. So this we can do. Silly. So this how do we do? Anyone?
I think
Just
that
We
take the
have a
unique
number
words.
of unique words, right?
Yeah. So we can keep on writing how
Much.
much
Wood.
wood
Would.
would
A.
be
Woodchuck. Chuck. If.
A is already there. Woodchuck is also
would
there.
we have counted as
Code is also there.
as
If
we
a wood,
have to count.
wood, could, chuck, wood.
last sentence, first word.
Okay.
As.
As much is there, wood is there, as is there, A is there, woodchuck, could, chuck.
Completed. It's
So,
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this we can check the answer. 9. Okay, good. Suppose we consider the three words wood, woodchuck, much. Assume that we use one hot encoded vector representation for all these vectors, words. The statement that the cosine similarity between the pair wood and woodchuck is greater than the pair wood much is. It is true or false?
It's false, no?
Yeah, why?
Because they're
Cosine
doing
similarity.
encoding and we need cosine similarity. And for one hot encoding, all the angles between all the vectors will be same. So the dot product will be same and the angles are same. So there is
Yeah, very nice. So what is the concept which we use here to find the cosine similarity?
the formula for cosine similarity.
No, not the formula. Maldi, what is the technique so that we start finding the semantic relationship between the words?
One hot encoding, no?
Yeah, we'll make
No.
the vectors.
Something was like that, no?
PMI. What does
Uh,
that mean?
Occurrence, for example, this is how. Okay.
This
And,
we will do in SVD, no? I think.
No, SVD okay, we'll do later on. But this is one of the technique where we start finding the relationship. So we make a window. So you make a window of 2. So window of 2 means for how these two words will come. So much and wood, which is there, it will come 1, 1. Then we move to much. So much will see two words here and two words here. So it will start finding the relationship between the words. Okay, just leave it here.
We have to calculate one hot encoding, no? Why you are calculating PMI?
No, this is the matrix that we calculated in GS and all, right? We
Yeah.
calculate we take the window and then we see if it is
Yes,
context
yes.
similar.
So I was just trying to explain that in case in this question, they have asked only one hot encoding. So we
Right.
know that okay, when we do one hot encoding, then we don't find any relation between the words. But if we use the PMI, then we start finding.
The
So a
context.
question, so if a question comes, okay, for example, they say that you have done the PMI, and then okay, the cosine similarity between this word and this word. So that how we can find out.
Right.
So this is false okay, that we have understood. Now we come to RNN model. Suppose that we need to develop an RNN model for sentiment classification task. The input to the model is a sentence composed of 10 words, and the output is the sentiment, positive or negative. Assume that each word is represented as a vector of length 100 into 1, and the output labels are one hot encoded. Further, the state vector st and the prediction y at t are computed as this, tan and softmax. The state vector st is initialized with all the zeros of size 50 into 1. Based on the above data, answer the given sub-questions. How many parameters first, including biases, are there in the network? So we'll attempt this. So what do? We make an RNN. So we know RN, how does it look like? Sentiment, the input of the model is a sentence composed of 10 words. So this will be the 10 words. And this is the last layer. And here is the S0 which we feed, which he has given. And this is one word we are giving. The output is sentiment. Assume that each word is 100 into 1. So its size is 100 into 1. Output labels are one hot and coded. So it's a sentiment classification. So output are 2. And the state vector is initialized with all zeros of size 50 into 1. This is the first one, 50 into 1. So this will also be 50 into 1. Okay, so this is W, this is U, and this is V. So how do we calculate the parameters? Parameters we'll have only for V, W, U, and we will have bias for U and bias for V. Okay, so we calculate V will be 15 to 2.
1 second. Why is it 50 into 2?
Because here it is a sentiment classification, positive or negative.
Okay.
Okay.
Right.
So this becomes 50 into 2 is this, and there will be one bias. So this bias will become 2. Okay. Now we come to U. U is 100 into 1 going to 50. So 100 into 50 plus bias. This will go to 50. Okay, so this became 50, 102. This will become
50.
And W will become 50 into 50 is equal to 2500. Just add it. Okay, what is the answer will come?
7702.
7702. Are you sure?
And you have to add 102 also.
702.
5050 plus 2550. 7702 you get.
102 C 52500 7550 is from here.
One sec.
505
Why have you gotten? Okay, we don't have bias for W.
W. Yeah.
That makes sense.
So 5050 plus 2500 is 7550.
1652. Yeah, it's correct. Correct. Okay.
Okay.
Hmm.
So it is 765. So we can check. It is correct. So what we have to learn from here, very, very important, that the bias here, there is no bias. Okay.
Sir, one more question about this RNA architecture that's predicting sentiment, right?
Yeah.
So for each word, like with traditional RNN, we have learned that the output of each time step is been passed to the next time step, right?
Yeah. So
But
in here, in
uh,
this kind of question,
it
where
will
we are
not
doing
pass,
this,
I
yeah,
guess.
where we are doing the sentiment classification, you are doing in the last only.
Yeah, last only. So that's
So
why the
last only
yeah,
here is coming.
right.
But if you see the number of parameters, whether okay, you find okay, for everything or you find in the last, the number of parameters remain the
The
same.
number of parameters will be same, right?
Yeah. But in this case, we are not predicting the next character or the next word.
Mhm.
There could have been a question, ki, for example, you feed, okay, for example, work, and your output should be, for example, office.
Hmm.
So in that case, your V would have changed. The dimension of input and output would have remained same. For example, if it is 100, then it would have become 100 into 50. For example, if it is 50 plus 50, hidden will become 50 into 50, and the output would have also become 50 into 100 plus 100. So that would have been the only difference.
Okay, so you are like assuming that the output is the word only, right?
Yeah, for example, if they're asking a question like we do in normal typing, when we type something, so there is something which is given to us
Mhm.
in a sequence. Like after every word like I feed, I type, okay, for example, while generating an email, if I write how, so it immediately gives okay, that how do you do and all that.
Right,
So that is a word okay. So it is happening in every that.
got it.
So we go to next one. For the given input sentence containing 10 words, how many sequential time steps does RNN take to make a final prediction? It is asking simple that how many are there. So how many are there in this question? They were there 10.
Yes.
Okay, so 10 it will do because at every it is making at every input it is updating the hidden state. So this hidden state is different from this hidden state, and this hidden state is carrying the whatever the meaning was there here. And similarly, this hidden state has carried here all. So the last one has carried all the relationships here from behind.
Can we conclude that, I mean, is this always true that the number of words are there, so those many layers will be there? Is that always true?
Mm, Uh, it will depend on the context of the question. But
I
okay,
mean,
you are right. That number of inputs which are there and that many number of layers will be there. Definitely.
okay.
As many number of inputs. If I'm giving four inputs, then again four layers will be there.
Right.
So this is easy 10. Now suppose we train the model using the BPTT algorithm for 200 iterations. In each iteration, we feed the input sentence and make a prediction, compute the loss, backpropagate through time, and update the parameters. How many times does the parameter matrix W gets updated over 200 iterations? So that is
It
also
should be 200, right?
yeah 200 because in every iteration it gets updated.
Yes.
Right.
Okay, just friends, okay, just give me 5 minutes. Okay, in the meantime, okay, you just solve okay, this question again. Just give me 2 to 3 minutes. Huh?
Yeah.
Yes, sure.
Thank you.
Someone please paste the question link. question paper link?
May 23 afternoon session, I think. I have it. Send it.
This is the September paper, September 2023.
Yeah, this is September 23. Last one. Okay, I'm back. Okay, so we go to next question.
A legit doubt.
Yeah.
Like, we have seen that we have 200 words, and we will update our weight matrix every time when we back properly. I mean, I'm not very clear with what iterations mean. Should we like come all the way to the start?
Okay. So I'll tell you. Iteration means you fed, for example, 10 words. Okay? These are 10 words,
Right.
and you got some output, and then you correlated, okay, with that the actual output, and then you use that to update your. So when you made one forward pass,
Right.
up to here, up to the output, and then you
One
made
second. When we're saying output, no, I thought we'll get output for every layer. Like we will get output for.
No. In this question, you are getting basically you are doing sentiment classification. So you feed, okay, for example, 10 words one by one, and then you find out that this sentence which is there consisting of 10 words, what is the sentiment, okay, conveyed by this sentence.
Okay, so for each word, will we not check the sentiment? Is that not
No.
how it is?
Yes. So there is no output for every layer.
No. So there will be output for every layer, but we'll just see the output at the last layer
No.
in the
No,
case
no.
of sentiment analysis.
नहीं, Bimlesh, in this, we can define that we are not giving any output. So
Yeah, I mean, generally we ignore the output till the last layer.
Yeah. So this is the forward pass we have made, okay, for one. We found out, for example, it was yes or no. We found yes. Now we make the backward pass, okay, that BPTT. Now we correlate with actual output, which might be no. And now we use this information, use the loss which is flowing back now to update U, W, and V, and along with the biases.
Makes sense.
So this feeding of 10 words and doing this is one iteration. So when we do 200 iterations, the parameters will be updated 200 times.
Got it. Yes.
Yeah. Okay. So now we come to next question. Okay, this is okay. Consider a skip gram model shown below. Each word in the vocabulary is represented as one hot vector of size 100 into 1. The embedding dimension h is 5 into 1. Enter the number of parameters, exclude bias in the entire network. So while discussing this question, we will discuss the concept of this skip gram and the continuous bag of words, just to understand.
Can you paste the link of this Jamboard again here?
Yeah, yes. I'm sending. Gone. Okay. Okay, just to understand the continuous bag of words and this skip gram. In continuous bag of words, what do we feed? We feed the context. So we feed, okay, for example, 4 words, and then we maximize the probability of the word, okay, which should be there in the output. Whereas in the skip gram, we feed 1 word, and then we maximize the probability of its context words. Is everyone clear, okay? Or somebody wants to ask something?
Does it mean that the continuous bag of word predicts target word from context and the skip gram predicts context from target word?
Yes, you're right. So I will just say, for example, here, for example, we take CBOW. CBOW here, the weight vector which is there, it is W context. This is word context. And here we give input like 1, 2, 3, 4. And output is like a single word. And this is words. Okay. Whereas in skip gram, what do? We feed 1 word. This is a layer. And output is its context words. So here it is W words.
So it's like
And
skip
here
gram
is-
is the opposite of CBOW.
Yes. And both, okay, where are we getting the word embeddings? Anyone, okay, if somebody can tell me?
Again, sir, question.
Where are we getting the word embeddings? Finally, we are interested in finding the word embeddings.
Yeah. So
From the word to vec algo, is it?
No. In this
No.
also we get word
In
to
this,
back, okay, has got 2 types: skip gram and continuous bag of words.
W words and W context, no, these are weights,
Yeah.
and it will get updated for the respective words. So W words a particular column and context particular column will give the representation of the word and the context, right?
Yes. So here, okay, basically here and here. In this case here and in this. Am I right, okay, Bhavya?
Where
Okay. Is that clear? This one? Or do we do it again? Okay. For example, you can go through some literature. It is available online. So both have got, okay, 3 layers: one input layer, one output layer. And in case of continuous bag of words, we feed the context words and we maximize the probability of the target word, which we know. So here it is the words context, okay, which we had found. Shall we revise, okay, that SVD also, if somebody wants?
Yes.
Yes, please.
because from there only these concepts have come. And this is CDOW, and this one is you feed one word. This is hidden layer, and you find the context words. So you feed it to this, and this gives to this. You're maximizing the probabilities of these words. Okay, so we solve this question first, okay, and then we discuss that also. So this is a question about the skip gram. So like I covered, we are feeding one word, and that word, each word in vocabulary is represented as one hot vector of size 100 into 1. So this size is equal to 100 into 1. The embedding dimension h is 5 into 1. This is the embedding dimension 5 into 1, the hidden layer. And now what we are predicting, we are maximizing the probability of 4 words. So the dimension of each word is what here? Here 100 into 1.
Yeah.
Yeah. Okay. So see the number of parameters here, it will become 100 into 5, 500.
In the first layer, yes.
Okay.
Yes.
And in the next layer, it is 5 into 100 and into 4.
5 into 100 into 4.
Yeah.
Why is it 5 into 100?
Because, okay, I'll go to the Jamboard again. Okay. Yeah. This is clear, 5 into 100, every word.
Yes,
Now,
yes.
this also, this full vector which is there, this is 5 into 100.
See, input was
Yeah.
one word and output are probably 4 words.
Yeah, so
And then,
the dimension of chair is 100 into 1.
each word is of that dimension.
Okay.
So this becomes 5 into 100.
It
Right.
is 4 words.
5 into 100.
There are 4 words. That is a multiplier of 4.
Yeah.
Each one is a 5 into 1. Makes sense. Makes sense.
Yeah. So this becomes 2000.
And plus 500.
2500.
So it's 2500.
There is no bias or bias.
They have written clearly, exclude bias.
If bias is there, then
If bias is there, then bias will come here, one bias. So यहाँ पे आपका 5 add हो जाएगा. And here with everyone there will be a bias, okay? So here okay, you will add 100 for everyone.
Okay.
If there would have been bias, what would have been the final answer?
Then here we add 505, and this
105 plus
2400. 2905.
it's 2600.
Okay.
Yeah.
100 with every word.
ठीक है. Correct. Yes.
So one more doubt in this question.
Yeah.
This, probably it's like a little bit dumb, but W context, W context, what will be the order of W context vector matrix? It's a tensor, sorry. Yeah.
Okay. So here only we can see.
It's
So W context hai here in n-gram. This is W context.
Yeah.
And this is a matrix like this.
It's a tensor basically, no? 3 dimensional.
It's a tensor.
Yeah.
Okay. So it will be basically 5 into 100 into 4.
5 into 100 into 4 or 5 into 4 into 100? That's
4. You can say 4 into 100 into 5 also. It depends on the representation.
No, but here, W context should be like that because H is R5, right? So W context, I guess 4 into 100 into 5 should be there.
4 into 100. That's what I'm saying. 4. You start from the outer.
Mm-hmm. Okay.
4, then 100, and then into 5.
Okay. Got it.
Okay, we come to next question. Okay. Consider an intermediate feature map H obtained after applying convolution operation on the input X using kernel F. Apply the max pooling operation with the stride S is equal to 2 and no padding P is equal to 0. And resultant output in matrix this. This question has got a problem. I had asked the clarification in the discourse and they had clarified that this is an incorrect question.
Yeah, but still let us try to understand.
Yeah, okay. Okay.
Why was the question incorrect? Can you also explain that?
Yeah, I'll cover it. Okay, let's understand the question. Consider an intermediate feature map. This is the map here. Apply the max pooling operation with the stride S is equal to 2 and no padding and store the resultant output HM. The problem in this question was here because here they have not given the filter size to apply the max pooling. So you can have output, for example, if I want, I can start from here, then second here, S is equal to 2. Is it correct?
अब अटक गए ना.
Huh?
If S is equal to 2,
Yeah.
okay, but यहाँ पे क्या?
Like one filter size I can put like 3 into 3.
3 into 3, yes.
Another filter I can put just 2 into 2.
No, but without padding it will be difficult.
So another I can put like a 2 into 2.
हाँ, कुछ भी कर सकते हैं.
So that will give me different.
Yes, yes.
So that was the problem in this question.
So let us try to solve this question assuming 2 into 2 filter.
Okay. Okay.
And stride is given.
Stride is given. And they are saying the prediction y hat is simply, so we say, for example, we assume filter size is equal to 2 into 2. Okay. So first 2 into 2, we select this. And the prediction y hat is simply the sum of elements in HM. Store the resultant output in matrix HM. Apply the max pooling operation with the stride S is equal to 2, no padding. Store this. Y hat is simply the sum of elements in HM.
So 3 will be there.
Okay, so here 3 has come, max pooling. Now we go to this 2,
2, 3.
3. We come here
Last layer.
1, 2, 1. So this will be the 2 into 2. And y hat is equal to
12.
2, 5, 3, 8, 12. Okay.
So this last row in H,
We cannot do. We cannot do.
anything.
So what is the gradient del L by del H10? So del H10 के we don't know, है ना? अपना size तो हमारा है ही नहीं. H10. Okay, H10 is this first row, or 10 is this. 10 will be this. Otherwise, again, this convolution operation we have understood again quiz 2. How to find
Need
x?
to divide that.
Yeah. Okay, we'll do that again later. So we go to first again next question, and so in this question paper, basically we have identified two things. One is this convolution wala that we will revise.
And the tower function also you admitted.
And the tower function. Okay. So, shall we move to next question paper again? So these two things again we will keep for tomorrow. So tomorrow again we will come prepared for this. है ना?
The tower function, okay, the initial fix.
Yeah. So this is over again this question paper. So we have got an idea what kind of questions they can come. So we solve another one. Okay. Okay, question is which of the following threshold theta value of MP neuron implements or Boolean function denoted by fx? Assume that the number of inputs xi to the neuron is 10 and the neuron does not have any inhibitory inputs.
1, right?
Uh,
No, it will be 0, 0, sorry.
Zero.
It has to be 1.
uh,
At least
if it
1,
is-
right?
It's greater than 0, no? So it will be at least 1 in this case.
Yeah.
Strictly
So,
greater than 0.
so this is clear again. So there is no problem in this.
स्ट्रिक्टली ग्रेटर कहाँ लिखा है? वो तो ग्रेटर लिखा है ना, क्या बोल रहे हो?
So greater, if it would have been greater than equal to, then it would have become 1. If it is
And if-
greater than theta, then it is 0. See our or function. How do we write? We write, for example, there are 10 inputs.
Any one,
So
any one, then it will become 1. If nothing is firing, then it is 0.
yeah. So in case it is 1 1 also, and in case all 1 also, then it
All
is 1.
0 is 0, and otherwise 1.
So in
So
all
that's-
cases greater than 0, all are this. In if this question would have become, for example, if I say and, then what is the answer?
10.
9, 10,
9.
10, 10. 10, 10. It starts from 0.
Why?
Because it is greater than.
Greater than,
Greater
yes.
than 9, no? The
Greater
greater
than
than 9 is 10 only. First element
Because
greater than 9.
if
9
we
we
write
can't include.
if we write 10, then also this condition will not fulfill. Then it will give 0. That's clear?
Okay, okay. Greater than equal to or greater than is making the
Yeah,
difference.
yeah. So here we have to see this part. Okay. So we go to next question. Consider the statement the attention mechanism in RNN based encoder decoder architecture helps the decoder to understand the context of words in a given sentence. That is true. Anyone with the concept of this attention mechanism?
Ananya.
Anyone?
Basically, we are giving the attention to the most important word. Means
So what do we do? Basically, this is the apna encoder, and its output we go to decoder. So when we do the attention mechanism here, so we are giving some semantic relation between the words to the decoder. That is the basic objective of the attention mechanism. And in transformer, there is a something called key
Self-attention.
self-attention, key query, and the third is also there. So it happens here also, and it happens here also.
Key query value, right?
Value.
Key query value. Now we go to suppose the MP neuron takes in 8 Boolean inputs x0 to x7 and produces the Boolean output y. Assume none of the inputs is inhibitory. Select all true statements. So this is the abhireka which you were mentioning.
Yes, I guess this is what I was mentioning. Yes.
Yeah. So this is very clear. Okay, this is from straight away formula. Formula is what? 2 into 2 to power x.
Number
And
of
this-
neurons,
and this is equal to number of
functions,
function, Boolean
clear
functions.
functions.
Okay. So this formula is there. There are 2 to power 8 possible functions. Incorrect. The function y is equal to max is not linearly separable. This is incorrect because we know that all these Boolean functions which are there, they separate here. And this is a linear separable. That is the basic concept of this MP.
Can you explain the last option, please? That next part.
Which one? This one?
Yeah, the last option. Yeah.
Okay, so basic concept is that when we make 2 to power 8 Boolean functions which are there, the idea is that only that whatever you give and or XOR or anything, it solves that. So it linearly separates again. So it is coming from that concept. It is not coming, I'm not specifying on the max. It can solve anything, all the Boolean functions which are there.
Okay.
Yeah, so basically 2 to the power n becomes a superset of all the possible functions you could apply using deep and neurons.
Mhm.
Yeah.
And this max is one of the functions.
Okay, this question comes from the understanding of, if I'm not wrong, from the bias and variance. So this also we can. Do this before seeing the answers. Okay. So now here, if we see the plot below shows the training loss, dark green cover. This is the training loss, and the validation loss here of a model over 8 epochs. Select all the correct statements about the bias and variance of the model. So can we say that initial our bias is low?
Yes, because difference is less.
Bias is low or bias is high?
Bias is low initially.
No, bias is,
Error is okay. Error is low.
this is loss. Okay. This is epochs. Okay. So see here. Here, this is the region of high bias.
High bias.
Okay.
And high variance. Variance is also high, no?
No, variance this we don't know. Now we come here, and now this is the part. Now the bias has become 0. Here bias has become low. Bias has gone down.
Variance is.
But the variance has gone up.
So in the first where you have classified that it has high bias, then at that point also the variance is high, no?
This is a high variance, yes.
That I'm saying.
Okay. So what is happening that with every iteration, the bias is decreasing, but checking from the validation. See, variance we can check only from the validation. But you see here, Ullas, the difference between the actual training and validation is low. So we cannot say that it is high variance.
Okay.
So this part is questionable. Okay.
Yeah,
But this is
why
very
are
clear
we
that
saying? Why are we saying high bias initially?
high bias because we are away from when the loss is high. It
The
means
loss itself is high, correct.
loss, my actual is here, but I'm predicting here. So this is my bias.
Correct.
Okay. And as we coming down, I'm coming close to the actual. So my bias is decreasing. Okay, but my variance has gone high. So let's see the
close to x equals to 5, there is sweet spot in which the bias is
bias and variance. Yeah. Bias and variance both are low. And in this noise is there. Therefore, bias and variance, they can never become 0.
Where is the noise mentioned?
If the noise is there, I made a statement.
Okay.
If noise is there, which is always there in all data, then bias and variance cannot become 0. Otherwise, it would have come here. This would have come here. Loss would have become 0. So with this, we check the statement. The model has a low bias and low variance at t is equal to 1, then at t is equal to 8. So this is false because bias at t is equal to 1, bias is high.
High bias, low variance as T1.
Okay. The model has a high bias and low variance at t is equal to 1. So that I was saying. Here, high bias and low variance.
You are saying that we can't conclude about the variance.
But variance, if we see this difference which is there, variance is basically this. How much we are varying. So in comparison to this, they are saying t is equal to 8. We have to compare. So t is equal to 8, the variance has become very high. So in comparison to this is low. Okay, it is relative. So that's why they're asking.
Like low variance with that.
Yeah. So model has a high bias and low variance at t is equal to 1, then at t is equal to 8. So that is true. The model has low bias and high variance at t is equal to 8. So that is true. Here, low bias and high variance. The model has high bias and high variance at t is equal to 8. False, low bias and high variance. Okay. So here we can understand high bias, low variance. Here, low bias, high variance. Is that clear again? Or again, I make this diagram?
No, it is clear.
Clear now?
Yes.
Okay. So we move ahead. Okay. Suppose that we have a deep feed forward fully connected neural network. The network is observed to have a high variance. Then which of the following techniques regularize the parameter of the network to reduce the high variance? So this is basically whenever we have got high variance, we use the regularization methods, and straight away from the lectures we know which are all the regularization methods which are covered. So
These
first
are
is
all the
the
regularization methods, but why the
yes,
last one is not there?
dropping hidden layers, because this is not a regulation method.
Dropping is also regularization.
No, not the dropping hidden layers.
We are actually dropping
dropping
neurons. Neurons is the
dropout में it was the neurons, dropping the neurons, not the dropping the hidden layers.
Yes, this is
Okay.
like wordplay.
Yeah. Yes.
The moment we see dropping, we keep thinking about neurons and we miss this entire sentence.
Yeah. Okay. So we go to next. The logistic function, sigmoid function is defined as this. The parameters are initiated to this through this. Suppose the loss is defined this. Whereby is the compute the gradient of W for the following sample. X is equal to 1, Y is equal to 1. This is a straight away calculation. Can we do
we
all?
have to calculate delta W, no?
Delta W.
You will be having the values Ullas with you.
Yeah. So this, how do we have to do?
That sigmoid curve formula we'll use.
And first we have to compute the value of fx.
Okay. I will just take a write here. Delta W is equal to Fx
Minus y.
F dash X, Y, and 2 Fx
Fx 1 minus fx.
1 minus Fx. And in this, for W we multiply by this by X also.
For w we have to multiply with x.
Okay. So what we'll have to do, Fx we'll have to calculate at X is equal to 1 and Y is equal to 1. Therefore, Fx is equal to 1 over 1 plus e to
E.
the power minus
0.5 plus 0.5, so it's minus 1. Minus 1, yes.
plus 0.5. So this value we have to calculate. Some value will come. Can somebody calculate this? Fast.
Sure. Is 2 power minus 1. 0.36. 0.735.
Yeah.
उन्होंने 5 सेकंड में कर लिया.
7.3. Okay. So now we have to calculate it straight away this only. So 0.73
minus 1
minus Y is 1. Then 0.73
0.27
0.27 and X की value is 1.
2.27 and 2.73. 0.053217. 0.053
0.053
217 minus it's
Okay. Have we made a mistake here? Some mistake?
No, you
say
gave the
it's
correct
correct.
input.
Huh?
You gave the correct input in this mouse.
FX.
You should check.
Okay.
Once you should check the answer, na?
आंसर चेक कर लेते because आंसर माइनस में नहीं है. ओके.
माइनस में है, सही है, बिल्कुल सही है.
तो ये वाला जो फॉर्मूला है ये बहुत इंपॉर्टेंट है, याद रखना.
ये सिर्फ सिग्मॉइड के लिए है. tan h ना पूछते हैं.
कि कौन सा 10h? वो 1 minus 10h square h है ना उसका स्ट्रेट अवे.
कौन याद रखेगा इतना?
बताना उसका फॉर्मूला 10h लिखना.
10h का अगर फंक्शन 10h है तो उसका जो डायरेक्ट डेरिवेटिव है वो 1 minus 10h square h है.
ठीक है
ना. जैसे अपना उसका था, किसका था, हाँ यही लगाते थे ना हम, क्या उसमें आरएनएन में 10 यूज करते हैं ना, 1 minus 10h square h.
डेल्टा w फिर चेंज हो जाएगा.
हाँ फिर डेल्टा w चेंज हो जाएगा,
इसलिए बोल रहा था.
हाँ. Okay, so this is the, and for the bias we don't use this.
Bias is x is removed, yes.
If bias का जाएगा तो then delta bias is equal to fx minus y.
तो
इसको
फिर
y
x नहीं
hat
आएगा
बोल
ना,
लो,
सेम
हाँ।
आएगी, वैल्यूज तो सेम ही आएगी।
y hat 1 minus y hat, बस।
ये भी 0.-0.05321 आएगा,
हाँ, बिकॉज x की वैल्यू 1 है इसमें,
1 है।
है ना? If x would have been different, then it would have been different. Okay, we go to next question. So this was a calculation point of view.
अच्छा, प्रीवियस क्वेश्चन के लास्ट ऑप्शन में अगर इंस्टेड ऑफ हिडन लेयर्स दे वुड हैव रिटन ड्रॉपिंग न्यूरॉन्स, तो क्या वो
Yes,
सही होता?
yes, okay, because dropout is one of the method for regulation.
हाँ, तो फिर वो करेक्ट आंसर होता है ना, अगर लिखा होता है
Yes,
कि ड्रॉपिंग न्यूरॉन्स।
Dropping
yes,
neurons in hidden layer.
yes.
अच्छा,
इन द न्यूरल नेटवर्क।
Because of that wordplay, many would have done mistake.
Yeah. Okay, we go to next one.
Because
this
if
was
we
a-
drop the hidden layer altogether, then it becomes disconnected.
या
Okay. So we go to next one. Consider a training set that contains 10 samples to train a neural network. Further, mini batch gradient descent algorithm has been chosen to update the parameters of the network with a batch size of 2. Suppose that we use an exponentially decaying learning rate scheme and t is equal to 1.5 exponential minus t by 2 and train the model for 2 epochs. What will be the value of the learning and t at the end of the training? Assume t starts from 0. Enter the answer to 3 decimal points. इसको भी ये भी कॉन्सेप्ट वाला क्वेश्चन है, कैलकुलेशन। सो Abir, you are keeping quiet.
Yeah, I'm paying attention.
Not attention. I was thinking. I hope things are becoming clear.
Yeah, they are becoming clear. Absolutely.
Okay. So see, in this question they have given there are 10 samples. Mini batch GD algorithm has been chosen to update the parameters of the network with a batch size of 2. Batch size of 2 का मतलब क्या हो जाएगा? 5 हो जाएंगे एक बार में,
5 yes,
है ना? एक बार में 5 हो गए और एक बार में 5 हो गए। Okay.
नहीं, बेसिकली बैच साइज ऑफ 2 तो मतलब 5 बार ही चलेगा ये,
मतलब वन
मतलब 5 बार
इपॉक,
ही अपडेट होगा।
एक इपॉक में,
हाँ, एक इपॉक में 5 बार
बैच साइज
होगा,
में,
सेकंड
हाँ,
में
ओके। तो 2 2 2 2 2 मतलब नंबर ऑफ अपडेट्स आपके 5 बार हो रहे हैं एक इपॉक में।
नंबर ऑफ अपडेट्स 5 बार होंगे और ये 2 इपॉक्स के लिए करना है, तो मतलब टोटल 10 बार अपडेट होगा।
तो टोटल 10 बार आपके हो गए। टोटल नंबर ऑफ अपडेट्स इज इक्वल टू 10। यूज एन एक्सपोनेंशियली डिकेइंग लर्निंग एन टी इज इक्वल टू 1.5 एक्सपोनेंशियल e टू पावर माइनस t by 2। तो इसका सिंपल आंसर होगा कि 2 इपॉक्स में है तो हमारे अपडेट्स कितने हो गए? 10 हो गए।
तो
ये हो
वी हैव
जाएगा
टू स्टार्ट फ्रॉम
1.5।
0। नहीं, 0 से स्टार्ट करना ना अपने t की वैल्यू, तो 9 आएगी t की वैल्यू बेसिकली।
हाँ चलो 9 हो गए, 9 हो गए। लेकिन यहाँ पे जो आपकी वैल्यू आएगी वो क्या आएगी? 9/2 या 10/2?
9/2।
हाँ, तो इसका जरा निकालना प्लीज।
0.016 आएगा।
हाँ,
0.016
एक मिनट इसमें देख लें। 1.5
इंटू
e टू
e
पावर
की पावर -2.5। एक मिनट 2 पॉइंट कुछ आएगी,
4.5 हो गया।
4.5 आएगी। तो हाँ, सही है, सही है।
0.016।
0.016 सही है, सही है। 0.016 आएगा।
ठीक है।
It's within the range।
हाँ, तो इसमें बेसिकली दे हैव आस्क्ड द क्वेश्चन है कि कैलकुलेशन तो वो है, इन्होंने कॉन्सेप्ट पूछी है बेसिकली कि ये वाला जो हमारी कॉन्सेप्ट क्लियर हो जाए कि बैच साइज 2 है, नंबर ऑफ 2 इपॉक्स हैं, तो नंबर ऑफ अपडेट्स कितने हैं, उसको सिंपल है कि हमें फॉर्मूले में लगाना है।
ये भी दे रखा है t starts from 0, तो ये भी चीज
हाँ,
याद
t स्टार्ट्स फ्रॉम 0 है, तो ये 9 हो गया हमारा, है ना? चलो वी गो टू नेक्स्ट क्वेश्चन। Okay. Consider an input image of size 100 into 100 into 3, where 3 is the number of channels. Suppose we apply a set of convolution kernels on the input image that generates the output feature maps of size 96 into 96 into 62. How many parameters, including bias, do the kernels have? That is, aggregate the parameters in the kernels. Assume stad s is equal to 1, padding is equal to p is equal to 1. ये भी understanding का पूरा क्वेश्चन है. So, पहले तो इन्होंने ये बोला है कि आपकी एक, मैंने अभी विमले से पेन ले लिया दोस्त.
बहुत बढ़िया इन्वेस्टमेंट है ये, अपने लिए.
हाँ, 100 into 100 और इसकी डेप्थ है 3. इसको कन्वर्ट कर लिया इन्होंने.
Then if you have Windows machine,
हाँ,
next time you use OneNote.
ओके ओके 96 into 96 into ऐसे ये हो गए 62. ओके, तो पहली बात तो हमें निकालना है फिल्टर साइज. फिल्टर साइज है क्या, यहाँ से निकाल लेंगे. तो हमारा क्या होता है फॉर्मूला, W2 इज इक्वल टू W1 माइनस F प्लस 2P अपॉन S प्लस 1. फॉर्मूला ठीक है ये वाला?
हाँ,
हाँ करेक्ट.
तो ये हो जाएगा 96 इज इक्वल टू 100 माइनस F, P इज 2, S इज 1, तो ये 1 हो जाएगा प्लस 1 इज इक्वल टू 102 प्लस 103. ये ठीक हो गया 7. अब इसको पैरामीटर्स निकालने के लिए क्या हो जाएगा, अब हमारा जो फिल्टर साइज हो जाएगा 7 into 7 into 3, ये हो जाएगा.
करेक्ट.
एंड into 62 है ना. और जो बायस होती है, बायस किस में जाएगी, सभी में जाएगी है ना, प्लस 62. ये निकालना आंसर उल्लास प्लीज क्या.
क्या एक बार रिपीट करना, मैं डिस्कनेक्ट हो गया था.
अच्छा अच्छा कोई बात नहीं. हमने क्या किया है, क्वेश्चन
7 आगे वैल्यूज वो तो ठीक है. उसके बाद
7 के बाद में व्हाट वी हैव डन नाउ, द फिल्टर इज 7 into 7 into 3 because 3 was the depth and 62 is the number, so we have to multiply by 62.
ठीक है. 9114
And now this bias
9176
कितना
9176.
9176. Let's see. Yeah, answer is correct. इसकी अंडरस्टैंडिंग किसी का कोई डाउट है क्या, हाउ आई डिड दिस क्या.
नो.
दोबारा एक्सप्लेन करना एक बार. 7 के बाद में कोई कांसेप्ट नहीं क्लियर हो रहा.
ओके, सो इसको मैं इधर ले आता हूँ. अच्छा, इसमें 20 ही फ्रेम बना सकते हैं, इससे ज्यादा नहीं बना सकते.
टाइम टू ओपन वन नोट.
ओके, वन नोट कहाँ पर ओपन होता है?
जस्ट सर्च इट. जस्ट सर्च इट.
स्टार्ट मेन्यू में जाओ.
यू जस्ट सर्च.
अरे पानी
नहीं, स्टार्ट नोट. ये
विंडोज का जो स्टार्ट है ना.
ओके
हाँ हाँ, वन नोट. जस्ट क्लिक ऑन वन नोट.
ओपन कर लो.
हाँ, if you cancel this, it should log you in either way.
अच्छा अच्छा अच्छा, कैंसिल कर सकते हैं इसको?
हाँ, कैंसिल कर दो. I think it should log you in.
ओके. Add page. Add page.
Add page.
Okay. ओके, इसमें यहाँ पर ना
And if you see on the right hand side where it is written add page, to the left of it there is an expand button.
This one.
Yeah. Yes. So now you can have all your pens and everything on your side.
Okay, very nice. So basically, just to revise the convolution network, so whenever there is an image, for example, they call it okay, 100 into 100 into 3. So this is the components of that image. So this is 100, this is 100, this is 3. And they said, well, it has been converted into 98 into 62. So this 62 is nothing but okay, these are the numbers of this. These many.
Yeah.
So
Three has
the
become, depth has become 62.
62. Okay. So filter kya size kya we have to find. So that we will find W2 is equal to W1
W1
minus F plus
plus
2
2p
P divided
divided
by
by
S plus 1.
plus 1.
So from here filter came 7.
7.
So when this is 7, so जो filter हम लगाएंगे this 7 है, so उसमें inherently ये जो 3 होता है, this 3 becomes a part of it. And this happens okay 62 times. So when we calculate the number of parameters will become 7 into 7 into 3 into 62.
So basically इसका formula आता है width of kernel into height of kernel into length of kernel into number of kernels.
And then when you put a bias, so there is a bias here. So this bias is applied to all the kernels. So this will become plus 62. So here the answer will become 9176.
76.
ठीक है? Yeah. So we go to next question. Okay. This is about. थोड़ा छोटा कर लेते हैं. Suppose this is a RNN for a binary sequence classification problem. So hidden state में there is a vector of size 2, output is of size 2, input is also of size 2, and the weight matrix and the U and V they have given 1 minus 1 minus 1 1. The state vector is computed as follows by using tanh function. There is no bias. What is the loss value? Use cross entropy loss with natural algorithm. Note in all your calculations, consider only the first two decimals. So what we have to see, the actual output, actual y value is 0, 1. We have to calculate a y hat. So how we will calculate y hat?
V into S.
Yeah, so this will calculate okay. This we go to one more. So we can add another page here
No
also?
need. You can just come down.
Okay. So this
Lalitji,
is
you have to click the draw once, like click the draw button above to the left corner menu bar.
okay.
No,
Okay.
above.
इंसर्ट के बाजू में ड्रॉ बटन ऊपर में. हाँ.
Okay, here.
हाँ.
Okay.
ये
So
कौन
this
सा
also-
वन नोट है वही?
This is like 2016, I think. It's different.
ओके. आप किसी पे भी क्लिक करो येलो पे, वैसा कलर वाला आप लिख सकते हो.
Okay. Thank you. Okay, so calculation करते हैं इसका फटाफट है क्या? तो कैलकुलेशन अपना हो जाएगा यहाँ पे S1 is equal to tan of H U into X1 plus W into S of 0. U है जन 1 minus 1 minus 1 1. This is 2 into 2. 1 into 0, 2 into 1. So this will become minus 1 and minus 1. sorry, this is +1 and this is -1. This is calculation is correct again, and then this will become W into S0. Oh, my one note collapsed. I did something wrong. 1 minus 1 minus 1 into
0 is 0, 0. Okay.
0. So this is 0, 0. This will become 1 minus 1 of 10h. So can we calculate it? Can somebody give me 10h of 1 and minus 1? If I'm not wrong, 0.73 minus 0.
Minus 0.76 and 0.76.
0.73 is the correct answer, no?
It's 7, 6.
Okay. Now we go to
अरे
H2.
एक बार ये भी देख लेते हैं कैलकुलेटर
But
में कहाँ
it
बोलता
is
है
in tan first vector -1 and 1. It is 1 and
वेर इज tan h in
okay.
calculator
0.76 and minus 0.76.
no we'll have tan h button in calculator
उसमें
I
अपना
Like formula or something.
नहीं नहीं TCS के कैलकुलेटर में एक बटन ही होता है tan h. So what we have to do is press 1 and then press tan h and then we'll get 0.76.
okay great
okay. So S2 will become again S1. S1 is 1 minus 1 minus 1 1 into 0 1 plus 1 minus 1.
Lalit sir, wouldn't it be -1 plus 1?
1 into 1 minus 1 into 0. So first we get plus 1 and minus 1 into minus 1 and 1 into 0.
It's correct.
Okay, na? Plus 1 minus 1 minus 1 0.76 minus 0.76. So this will become 1 into 0 minus 1 1 plus 1 0.76 plus 0.76 plus 0.76 is equal to, this is 1.52 1.52 minus 1
Yes, 1.52.
52. This is minus 1.52 and this minus 0.52.
158. Yes, yes, yes.
अब इसको करना पड़ेगा हमें v से मल्टीप्लाई. v अगेन 1 minus 1 minus 1. इसका 10h निकालना पड़ेगा ना पहले. इसका 10h निकालेंगे कोई? 10h 0.52. minus
0.47 minus 0.47 minus का माइनस वाले के लिए प्लस वाले के लिए
0.47.
Sir, wouldn't you add both and then take the tan h?
कौन सा?
he added no
Acha, he did add. Okay.
-1 plus 1 -1 1 he added no
we have calculated S2 now, then what we are calculating next? After S2,
अब इसका निकलना है हमें सॉफ्ट मैक्स.
ललित सर S2 के बाद आपने क्या करा, क्या कैलकुलेट करा?
S2 आ गया हमारा. S2 आ गया 10h निकाल के ये वाली वैल्यू आ गई.
वो तो आ गई. उसके बाद क्या करा?
कौन सी वैल्यू आई थी? 0.47 आई थी इफ आई एम नॉट रॉन्ग. 10h की ना. उसके बाद इसको इसके बाद हम यहाँ पर गए v से मल्टीप्लाई किया ये लेने के लिए. तो ये वैल्यू आ गई. अब इस पे सॉफ्ट मैक्स लगा दो तो y हट आ जाएगा.
एक ही बार मैं करता हूँ.
हाँ
So would it be softmax or would it be sigmoid? Because the answer is binary.
एक मिनट देखते हैं उसमें क्या दे रखा है क्वेश्चन पेपर में. क्वेश्चन पेपर में
But it's not mentioned. But the output is binary. So wouldn't it be
नहीं
sigmoid?
से
क्रॉस एंट्रोपी उसको.
क्रॉस एंट्रोपी दे रखा है ना, उन्होंने हिंट दे रखी है. सो क्रॉस एंट्रोपी हम सॉफ्टमैक्स में यूज करते हैं हमेशा.
Okay.
इसको भी निकाल सकते हैं.
0.94
हो जाएगा
2.55 आएगा. ई की वैल्यू 0.94. यहाँ पे डायरेक्ट ही कैलकुलेट कर लो. हाँ
हाँ ये तो कर मैं. क्या वैल्यू आई थी हमारी 0.47.
ऊपर माइनस का था, देखना एक बारी. हाँ एक माइनस का प्लस का करना है बेसिकली अपने को. गलत.
जीरो 0.72 और इसकी हो जाएगी -0.28.
मतलब टोटल 1 आएगा तो सही है. सॉफ्टवेयर में सही कंप्यूट करें.
तो ये हो जाएगा
0.72
0.28.
0.28.
क्वेश्चन में क्या पूछा इन्होंने?
Loss.
What is the loss value? So loss value will become इसमें अगेन यहाँ पे ड्रॉ करके कलर चेंज कर सकते हैं ना.
No, you can scroll down and then do it space.
You can write something like okay. So loss will become y की वैल्यू क्या थी एक्चुअल में क्लास उसमें देखेंगे क्वेश्चन
1,0 था. मतलब
1,0. सो ये हो
नीचे
जाएगा.
चले जाओ, ऊपर लिखने की जगह नीचे आ जाओ ना.
अच्छा ओके. सो लॉस इज इक्वल टू माइनस y इंटू log n y hat -1 इंटू log n of 0.72. इसका निकालेंगे प्लीज. log n of 0.72
0.72 तो -0.32.
-0.32. यहाँ पर हमने कैलकुलेशन में कहीं पे भी एरर किया है बिकॉज मैंने पहले सॉल्यूशन किया था.
तो 0.32 आएगा इसका आंसर. कितना आ रहा है आंसर सही कर. करेक्ट आंसर कितना?
देखिए 1.952 दे सके. कहीं पर हमने उसमें गलती की है कैलकुलेशन में.
गलती करी कैलकुलेशन.
फिर से कर लें इसको जस्ट टू गेट कॉन्फिडेंस एंड ऑल ऑफ अस कैन वी डू इट.
यस ऑन अ फ्रेश पेज देन. नीचे
है ना.
यहाँ से हटा के दोबारा करते हैं.
इसको कॉपी कर सकते हैं ना.
हाँ
और यहाँ पे इसको पेस्ट कर सकते हैं.
हाँ.
वेरी गुड. ओके. तो यहाँ पे पहले हम S1 निकालते हैं.
y की वैल्यू 0. एक मिनट. y की वैल्यू 0.1 है. 10 नहीं है.
0.1
अभी सही आ जाएगा. हाँ अभी सही आ जाएगा.
0.1 है तो
0.2 होगा. एक मिनट रुको मैं निकालता हूँ.
हाँ
तो -1.27 आ रही है. मतलब 1.27 सही आंसर होगा. देखना क्या आंसर. अभी
नहीं गलत है.
फिर भी गलत है.
गलत है. मैंने पहले सॉल्व किया था ये. कहीं पे कैलकुलेशन की गलती हो रही है हमारी. यहाँ पे निकालते हैं. चलो S1 निकालते हैं. S1 is equal to S0 W into SW plus U into X0. W है हमारा 1 minus 1 minus 1.
x0 लिखते हैं या x1 लिखते हैं. आई मीन जस्ट फॉर नोटेशन.
हाँ x1 भी लिख सकते हैं. x1 होता है. So 1 minus 1 minus 1 1 0 0 तो ये तो पूरा 0 रहेगा. 1 minus 1 minus 1 1 into 1 0 is equal to.
ये u और w दोनों से सेम है क्या?
सेम दे रखा है क्वेश्चन में.
ओके.
1 into 1 1 minus 1 into 1 minus 1 is equal to
1
10
minus
H
1.
of 1 and minus 1. ये हमने निकाल ली थी 0.76 एंड माइनस 0.76. तो यहाँ तक तो हमारा ठीक है, आई थिंक, है ना. अब क्या हम निकालते हैं H2 पहले. H2 is equal to W into S1 plus U into X2 is equal to 1 minus 1 minus 1 1. Mm-hmm. 0.76, 0.76, 1.52.
No, wait.
हाँ,
Why H2 has this formula?
कौन सा वाला?
H2 equal to WS1 plus UX2.
ये वाला यहाँ पर है ना, ये वाला H2. फिर इसका हम 10 निकालेंगे H2 निकालने के लिए. फॉर्मूला तो वही हो जाता है ना, W into S1 plus U into X2.
Okay. हमने पहला लेयर पे S1 कैलकुलेट किया, दूसरे
हाँ.
लेयर पे S2 कैलकुलेट करेंगे ना.
हाँ, यहाँ पे H2, उसके लिए पहले हमने H2 कैलकुलेट कर रहे हैं, फिर उसका 10 ले लेंगे H2 निकालने के लिए. इस जगह प्लस, यहाँ पे 1 and 2 0 minus 1, वही जगह प्लस 1 2 minus 1. इसका S2 is equal to 10 H.
Tan H of 0.52 is 0.47, is it?
Yeah, but just see somewhere we are making some mistake, some stupid mistake.
See, S1 is clear, no? Till S1, 0.76 minus 0.76 is okay. Okay.
Right.
So after calculating S1,
Yeah.
and then we have to calculate H1.
H2, H1 तो ये था, और यहाँ पे S1 हो गया था.
S1 is equal to H1 हो गया है.
नहीं, S1 is equal to 10H of H1 हो गया था.
S1 is WS0 plus UXI, correct?
No,
Right.
no, this is H1. S is equal to S1 is equal to 10 of H of W into S0 plus U into X1. So this we calculated, which we got okay, 0.7, this 1 and minus 1. उसका
And
10,
then we calculated tan H.
10.
So we got this S1.
Yeah.
So after S1 we calculate H1.
Yes.
So what is the H1?
H1 तो ये रहा ना, H1 तो
So
ये
H1 is W S0 plus U X1 below G. After that,
one and minus 1.
yeah. After 2 H1 we apply tan and we get S1.
Okay.
Yeah.
So we calculated H1 from S0, then we calculate S1, which is some function of H1, and then we are feeding that to layer 2.
Yes.
तो फिर H3 कहाँ से आ रहा है?
अब ठीक हो गया. H3 ये है, जस्ट अंडरस्टैंडिंग के लिए H3 यहाँ पर है, यहाँ पे H2 है, यहाँ पे H1 है. ठीक है इंग्लिश?
I understood H2. H3 like little.
नहीं, you can call it H3 or you can call it A3 also. Just write it A3. Okay.
And what are we doing to get H3? I mean A3.
V into S2.
Okay. Okay. We have S2 previously and then we multiply with V in H3. Okay.
Yeah. So this will become 0.98 minus 0.98. Therefore, y hat is equal to softmax of 0.98 minus 0.98. Now this we can calculate. This will become 0.87 is equal to 0.87 and 0.13. Now, therefore, loss is equal to y क्या था 0.1 था ना
1.3 के सकते हैं।
हाँ
0.1 बता रहा था उल्लास।
Yes.
हाँ इसकी वैल्यू निकालना उल्लास प्लीज
So एक मिनट
ln of 0.13 is it?
minus 0.3 तो
नहीं
ये
माइनस
minus 2.04 प्लस अरे ये तो कॉम्प्लेक्स नंबर्स में आ रही है वैल्यू
नहीं 2.04 है
2.04 माइनस का आ रही है प्लस 3.14 आयोटा
हाँ सॉरी यहाँ पे मैंने ये गलत लगा दिया था ये प्लस ही है प्लस है
हाँ अब ठीक आ गई एक मिनट देखता हूँ
2.04.
अरे बट उल्लास नेगेटिव का ln तुमने निकाला कैसे?
वही तो मैं पूछ रही थी.
अरे वो क्रोम में डायरेक्ट टाइप कर रहा हूँ ना तो
ठीक है
कॉम्प्लेक्स नंबर मैंने पहली बार सुना।
आप भेजो क्या ग्रुप में
भेजो
अब एकदम ठीक आंसर है 2.04 हमने लास्ट में पता है कहाँ गलती की थी वे वी मेड द मिस्टेक
You didn't calculate H3 is it?
नहीं
Directly.
यहाँ पर
So can we quickly go over
this into 2 होता here के we made a mistake एक को मैंने 0 कंसीडर कर लिया था
1 second. Laji, could you scroll down to A3?
yeah
A3, how much have you gotten? 0.98.
yeah here we have made a mistake
एक से वापस
ये मेरा वन नोट है क्या इट
अरे
इज क्लोजिंग डाउन एंड अगेन ओपनिंग
धीरे-धीरे आ जाएगा कोई दिक्कत नहीं है मेमोरी में ले रहा है
you can update it
क्या जरूरत है नहीं आप डायग्राम पे जाओ एक बार
ओके
ये डायग्राम में जो नेटवर्क है 2 लेयर दिया हुआ है ओके
हाँ 2 लेयर है देखो अब मैं इसको एक्सप्लेन कर देता हूँ
इसमें S0
ये यहाँ पे
आर्बिट्रेरी फीड हो रहा है
हाँ S000 है ये X1 है इन दोनों को यूज करके हम H1 निकालते हैं H1 इसका इनपुट है इस पे हम 10H लगाते हैं और यहाँ पे S1
निकालते हैं करेक्ट
हाँ एक मिनट फिर से खुलेगा ये इस पर
डायग्राम पे जाओ
हाँ डायग्राम पे फिर से जाता हूँ
नहीं इसी क्वेश्चन नहीं इसमें हाँ इसमें ये है कि आपका हिस्ट्री रह जाता है
हाँ अब देखो यहाँ पे आपका S1 आ गया
नहीं अब दोबारा से वो लिखो एनोटेट करो
गलती क्या कर रहे थे अपन कौन सी कैलकुलेशन में
यहाँ पे ये वाला जो फर्स्ट पार्ट है ना 0.47 यहाँ तक हम ठीक आ गए थे ये जो मल्टीप्लिकेशन किया था A3 का हमने इसको 0.47 ही ले लिया था जबकि ये 0.47 into 2 होता
अच्छा
हाँ ये गलती
डायग्राम नीचे चलते हैं S0 से हमने 10H लगा के H1 निकाला
नहीं सुनो H1 को हमने निकाला X1 into U S0 into W को दोनों को जब ऐड किया तो मेरा आ गया H1
हाँ ओके
H1 को इसमें फीड किया 10H में और निकल आया S1.
ओके
अब S1W एंड UX2 को मल्टीप्लाई किया तो मेरा आ गया H2.
हाँ
H2 पे मैंने 10 लगाया तो मेरा निकला है S2.
great.
S2 को मैंने V से मल्टीप्लाई किया तो मेरा आ गया A3. A3 पे मैंने सॉफ्ट मिक्स लगाया तो मेरा क्या आ गया Y हैट.
सॉफ्ट मैक्स हम इसलिए लगा रहे हैं क्योंकि क्रॉस एंट्रोपी लॉस
क्रॉस एंट्रोपी. यस.
सिग्मॉइड के लिए क्या होता है?
सिग्मॉइड के लिए अपना ये होता है ये y माइनस वाई हैट स्क्वायर, उसी का तो हम वो निकालते हैं. सिग्मॉइड का जब हम डेरिवेटिव निकालते हैं,
करेक्ट.
हाँ, y माइनस वाई हैट स्क्वायर. और
ठीक है,
इसके
ये
ऊपर
नेटवर्क
फिर
समझ में
हमने
आ गया.
इसके ऊपर हमने कर दिया लॉस फंक्शन यहाँ पर y एंड वाई हैट को, जो कि हो गया होता है माइनस वाई इंटू लॉग ऑफ नेचर वाई हैट.
एक सेकंड, जस्ट फॉर क्लैरिटी, ये वाई जो आउटपुट लेयर में बोल रहे हैं सिग्मॉइड लगाने के लिए,
सॉफ्ट मैक्स
ना यहाँ पे सॉफ्ट मैक्स लगा, आप बोले सिग्मॉइड भी लगेगा, इज इट?
नहीं
सिग्मॉइड में क्या होता है?
question was that if you use sigmoid then what will be the loss function. So for the sigmoid the loss function is y 1 by 2 multiplied by summation of y minus y hat whole square.
बट अगेन अगर सिग्मॉइड लगाएंगे तो फिर वो तो 0 to 1 का आउटपुट देगा, राइट?
हाँ, वो 0 to 1 का आउटपुट. नहीं, सिग्मॉइड में भी 0 to 1 का आउटपुट नहीं देता है. sigmoid also gives a probability distribution.
या सो वो 0 to 1 होगा, राइट?
हाँ, 0 to 1 एडिंग मतलब एक की वैल्यू 0.23 आ जाएगी, एक की 0.77.
सिग्मॉइड बेसिकली, सिग्मॉइड जितना तक मेरे को याद है वो लास्ट लेयर में सिग्मॉइड नहीं रहता है ललित सर. लास्ट लेयर में नहीं रहता है तो आप उसका लॉस फंक्शन क्या होगा ये कैसे बताओगे फिर?
नहीं, लॉस फंक्शन तो उन्होंने कवर किया था और लॉस फंक्शन आप निकाल सकते हो. आई जस्ट कवर इट हियर ओनली. नीचे ट्रैक कैसे होगा?
Lalit ji, doubt. If you scroll down for A3, you got 0.47 plus 0.47 first element in A3, right?
Yeah.
Scroll little down, more down.
I'm just second. My mouse is not working. I don't know why. This one note is giving me some problem.
I think you have to update it. That is what it's causing.
Yeah, no problem. Yeah, tell me.
We have 0.47 plus 0.47. That is 0.94. How have you got it?
Okay. So 94 का भी अपने कर लीजिए.
2.94. And then after that, we have to apply softmax to this.
हाँ, लगाओ softmax इस पे. Nine four. .87.
Okay.
कुछ बोला कैलकुलेटर यूज करना सिखा देगा.
Shall we move to next question? Acha, what the question was, if you use sigmoid decay, then the loss function. Sigmoid decay अगर देखो, f of x is equal to 1 over n plus or minus x. This is a sigmoid function. And loss is always, आप एंट्रोपी भी जो लगाते हैं, एंट्रोपी के बाद में आई जस्ट कवर इट. लॉस इज ऑलवेज y minus y hat. This is the loss.
Yes.
Okay. Now when you use the cross entropy का when you come down to the soft max, यहाँ पे you put a soft max, यहाँ पे you did a loss function is equal to minus y of y hat. And when you take out from the soft max, what do you get? You get y hat minus 1. And this is nothing. It is y hat minus y. So here you get y hat minus y only, which you desire. That is the reason for soft max we apply cross entropy loss, because we need this. Similarly, when we do for this one, यहाँ पे directly you can put here that loss is equal to fx of minus y, and that's why that delta for sigmoid here, which comes is fx minus y fx. This term is coming 1 minus fx. So for this you use loss function for sigmoid is equal to half into fx minus y square. And when we do the derivative of this loss function, that time okay, this value comes.
ये sigmoid वाला सर ये कैसे हुआ माइनस वाई ln y कैप?
Okay, just hold on, just hold on. जैसे कि प्रोफेसर ने पूरा इसका डेरिवेशन किया था, so your fx is equal to 1 minus 1 over 1 plus e to power minus x.
Right.
Loss function for this is equal to 1 by 2 fx. Come to
MSC mean square error y cap
yeah.
y cap minus y whole square.
Hello.
Your screen is frozen for me.
Yeah. This was not working. I think OneNote is giving me problem. So finally, when you use the MSC error, so then okay, you get that loss function, get that derivation which is there, which we had used earlier in that question. Hello, am I audible now?
Yes.
Yeah. So can we move to next question, please?
Yes.
Okay. So this calculation part was good. So this is the same question which we have solved again, previously. Consider fully connected feed forward, 3 hidden layers, W1, 10 and 200.
Exactly same.
Yeah, so this we have done. In this okay, why 163 is coming? Same layer he has. इसने 50 का 150 का 50 he has done. That's right. In that question it was 150. Learnable parameters we know how to calculate.
कैलकुलेट करें एक बारी 150 का ऊपर करना है.
Okay, we will do it again.
अच्छा यहाँ पे 100 हाँ ठीक है 100 plus 50 plus 10 plus 3
है ना?
ठीक है correct.
This is slightly easy. So the statement that in general the activation function of neurons in the network are not necessarily be the same across the network is true or false?
True.
That
We can have different.
They can be different. That we have seen. Then consider a sentence inside the quote, I may be wrong and you may be right, and by an effort we may get nearer to the truth. Based on the above data, answer the given sub-questions. What is the size of vocabulary that we can calculate? That is
16
easy.
unique words. Okay.
Yeah. Suppose all words in the vocabulary are represented using one hot encoded vector of size v, then compute the ordered pairwise, that is Cartesian product of v into v, cosine similarity between two word representation and enter their sum.
16.
16.
अरे
Yes.
ये क्या क्वेश्चन क्या पूछा भाई? आंसर तो बोल दिया.
हाँ?
अभी तक बोल रहा हूँ, क्वेश्चन तो समझा दो पहले.
Okay. So what they are saying, make a Cartesian product of v into v. First you do the one hot encoding of all the words, then you make the Cartesian product, and then you calculate the cosine similarity between two words. So then what will be the sum of the cosine similarity between two words representations and in entire that matrix?
The Cartesian product will have how many members? V cross V, 16 cross 16.
Yeah. So again I will open this.
अपडेट कर लो ना Microsoft.
Okay. So this will be 1, 2, 3, 4 मतलब 16 यहाँ तक हो गए. 16 यहाँ तक हो गए.
Correct.
ओके. तो इनका बेसिकली कॉन्सेप्ट है कि ये अंडरस्टैंडिंग होती है कि इसमें ये जा रहा है मेरा. तो मैं जैम बोर्ड एक खोल देता हूँ. एक और खोल सकते हैं ना इसमें?
हाँ.
Abir, can you explain this again, Fiona?
The question.
Yeah,
Question:
first,
how we are getting the answer?
first explain the question, what it is asking.
So we all know the fact that one-hot encoding does not encapsulate the context of the words or the set of words, right? So, but they have mentioned something specific, very specific in the question, which is to get the pairwise Cartesian product, right?
Correct.
So if they had not mentioned the pairwise Cartesian product, like the question that we did previously, the answer would have been 0. But they have said pairwise Cartesian product, which simply means x times x transpose. So if you take a word or one-hot representation of a word and multiply its transpose with itself, then the answer will be 1.
Okay.
So you have to do the same thing with 16, all 16 words, multiply the word one-hot encoded representation of each word with itself, with the transpose of itself, and the answer will be 1 for each. You sum all 16 up, the answer is 16.
Okay, Bimlesh, it is like this.
So
Abir,
Cartesian
thank you. See,
matrix will be 16 cross 16, correct?
okay. Just Bimlesh, this is 16. This is 16. Only the diagonal elements which are there, they will have 1. Okay. Rest all values will be 0.
0 will come because of the one hot product.
One hot product, and there is no similarity.
Yes.
Okay. So when you sum like these, this will become 16.
Let us see how one element is coming 0.
For example, I will give you an example of 4 words only. So
Okay.
one will be 1 0 0 0. Another will be 0 1 0 0. Another will be 0 0 1 0. Another will be 0 0 0 1. So you multiply any one, cosine similarity is equal to A into B divided by A cross B and divided by absolute of A and B. So when you multiply 1 0 0 0 with any one 0 1 0 0, it becomes 0 0 0.
Yes, because this is like straight
Okay.
kind of
So
element wise calculation.
now, so when you extend this to 16, only with this word, when it gets multiplied with itself, it gives 1. With everyone else, it will give you 0.
Yes,
And that's
because
why the sum
access
will,
transpose will become
yeah.
great.
And that's why sum will become 16.
And if cosine something Abir was telling you, if cosine similarity something was not given, then answer would have been 0. What was that?
No. If they would have said that don't find the pairwise Cartesian product, then it would be actually the question would be very different. Like the previous question they had asked us, right? They had given 3 words and they had asked us these are one-hot encoded words and what's the cosine similarity between them, or cosine similarity of one pair of words will be greater than the other, and the answer would be false because the cosine similarity of all those
0
words will
everywhere.
be 0.
Correct.
Right.
Correct. Great.
So we move to next question. Okay, the update rule for the atom is this. Atom ka we know that both MT and BT are initialized to 0. Yes, that we know that. However, the update rule uses the bias corrected version of MT and BT. Which of the following is the bias corrected version of MT? So we know that straight away उसका तो
डिवाइड करते हैं ना वो वाला.
what we do? कहाँ चला गया? My laptop has become slightly slower. Am I audible?
Yes. This
Yes,
is
you are
due
audible.
to pen.
Okay. ये तो straight away formula से है हमारा, and we know that also कि if we don't do the bias correction, what happens? So if I'm not wrong, MT hat is equal to MT plus 1. MT plus 1 is equal to 1 minus beta t minus 1, and similarly vt hat is equal to vt upon यही था ना
सही पूछ
तो mt is equal to beta 1 t plus 1. यहाँ पे we will have to check our notes है क्या? I think so. For
Yeah,
this,
we just have to refer the formula.
है ना? So we'll have to, because what I remember, this was the formula which I've learned, the first one. Anyone having his notes here? Any register? I'll just open mine here. I'll just check. Okay. The professor, what he has covered the first option. Empty hat is equal to empty divided by 1 minus beta 1t. हेलो
फिर ये आंसर ये बी क्यों दिया
हाँ तो इसको हम डिस्कोर्स में डाल सकते हैं ना
यस यस
हाँ so इसको we'll see clarification on discourse because I remember notes I have opened my notes and it is clearly given first option.
No, but what is the second option? ये look ahead वाला कुछ है क्या?
नहीं ये एडम का है एडम का simply they have asked कि what is the update rule for empty.
तो गलती से भी उन्होंने बी क्यों दिया आंसर?
कौन सा?
B option B which is in green.
हाँ हाँ
1 divided by 1 plus beta it got beta t plus 1 है ना?
हाँ हाँ हाँ
वो कैसे हो सकता है at time step t?
चलो इसको पूछ लेते हैं डिस्कोर्स पे.
Okay.
Okay, now this question comes again with the understanding of that. So consider a model shown below that learns the distributed vector representation of words by learning to predict the target word given the context word. Okay, ये उल्टा है. इसमें context word दिया गया है and target word है. So this is क्या कौन सा मॉडल हुआ ये हमारा? Continuous bag of words.
Yes.
Okay. And continuous bag of words में also they are saying कि they are giving only one word. So it is like कि we are giving input one word and जैसे हमारे email में होता है या WhatsApp में होता है that second word is coming as a clue what to feed. So consider a model shown below that learns the distributed vector representation of words by learning to predict the target word VW given the context word UC. Here VW and UC are the vector representation of target word at the index W of the output vocabulary and the context word at index C of the input vocabulary respectively. So in the diagram, V denotes the size of vocabulary, W context and W word are the learnable parameters. The vector representation for all context words are arranged as columns of W context and the vector representation for all the target words are arranged as row vectors in the W word. The parameters are initialized randomly. The input X is one hot representation of a word in the input vocabulary. Assume that the size of both input and output vocabulary are equal. So इसको एक हम उस पे बना लेते हैं पहले just understanding के लिए. That how does it happen? मेरा बिमलेश ये काम नहीं कर रहा. Shift print is shift window and S.
विंडो शिफ्ट
विंडो शिफ्ट एस करेगा
आया थोड़ा लेट आया. I think कुछ कहीं पर कुछ
लैग हो
ज़्यादा
जाता
हाँ.
कभी लैग हो जाता
Okay, so we understand this question basically. This is like we are giving one word and this is the hidden layer and here we have to predict that after this word this इसका size हो जाएगा V. यहाँ पे कुछ भी size हो सकता है H और यहाँ पे different words हैं and we have to maximize the probability. For example, if this word is for example sad, सो जितने भी वर्ड्स V में हैं उसकी प्रोबेबिलिटी निकालनी है ऑफ प्रोबेबिलिटी फॉर एग्जांपल A over set. Okay. And all this size will be, and we know that correct के जो होता है that should be P. Okay. P correct is on public set. So all these probabilities we'll get, we have to maximize only the probability of this n. Okay, and this is at a place W, and all these are at a W dash, which will go from 1 to V. This is the question. Now we check the options here. What is it? Suppose the input is X, one hot representation of context word, and the corresponding label is Y, one hot representation of target word. The quantities H, UC, Y hat are computed as follows. H is equal to UC is equal to W context into X. So here is the UC, H is equal to UC is equal to, this is W context. So this is W context into UC. Okay. And Z is equal to W word into UC, W word into UC, and Y it is equal to softmax of Z. Here he's saying this is the Z. Z is here. Z is equal to, this is W word into UC, and Y hat is equal to softmax of Z. ये क्लियर हुआ थोड़ा विमलेश? क्या shall I explain like this? We are
Yes,
please.
ये
Okay.
नेटवर्क जो है, नेटवर्क में हम लोग काइंड ऑफ एरो ऑफ वर्ड्स दे रहे हैं इनपुट.
हाँ, फॉर एग्जांपल जो सेट है, सेट फॉर एग्जांपल इज रिप्रेजेंटेड एज 10000 फॉर एग्जांपल. देयर इज अ डब्ल्यू कॉन्टेक्स्ट मैट्रिक्स, यहाँ से यूसी बनता है. दिस इज नथिंग कि इसकी जो एम्बेडिंग है इस वर्ड की, उसके बाद में जितने भी वोकैबुलरी में जो वर्ड्स हैं, वी नो दैट क्या, दैट सेट के बाद में ऑन आना चाहिए, बट इट विल गिव प्रोबेबिलिटी डिस्ट्रीब्यूशन फॉर ऑल द वर्ड्स. So
Yes.
W word we multiply this UC which we have got. So for every word we will get a probability which we are getting from softmax.
So that
And
summation, that will be some summation of all those probabilities will be 1.
Yes, yes. But again we have to now maximize. किसका हमें maximize करना है? इसका.
Okay.
So जब हम soft उसमें करेंगे तो we have to maximize. So now we now start understanding. So softmax Y hat is equal to, for example, if we calculate for this, he's at W position, will be EW summation of EW hat. W hat is from 1 to V. This is correct?
V is the vocabulary. Okay.
Huh?
V is vocabulary.
V is vocabulary size. So ये ठीक है ना ये वाला? तो इसको हमें मैक्सिमाइज करना है. इसको मैक्सिमाइज करेंगे तो क्वेश्चन ये क्या पूछ रहे हैं, पहले ये देख लेते हैं. हमने पहले ये कर लिया. चूज द एक्सप्रेशन दैट द मॉडल हैज टू मिनिमाइज यूजिंग क्रॉस एंट्रोपी लॉस. Using cross entropy loss. Okay. So इस केस में आपका ये बहुत ज्यादा बड़ा हो गया. क्रॉस एंट्रोपी लॉस क्या होता है? माइनस वाई इंटू लॉग इन
log of y hat.
वाई हैट है, ये हो गया।
Yes.
वाई हैट की जगह यहाँ पे 1 हो गया, इसको हमें 1 करना है, तो ये हमारा हो जाएगा माइनस वाई हैट की जगह ई डब्ल्यू समेशन ऑफ ई डब्ल्यू हैट। नाउ डब्ल्यू जो है, we know that what is the value of w hat है? This is w word into uc,
Yes.
है ना? तो इसको इसके फॉर्मूले में लगा के y hat को, और इसको जब हम कर रहे हैं log in of y, और ये जो e है, e का जब हम log in लेते हैं तो क्या जाएगा हमारा बाहर निकल के? इसको जरा पेपर पे निकाल के कोई फॉर्मूला लिखेगा उल्लास से? क्या यू आर गुड इन फॉर्मूलाज?
कौन सा फॉर्मूला उसका?
y hat जो है वो है अपना माइनस, सॉरी, सॉफ्ट मैक्स of z. Z is nothing. Z is w word into uc. uc is nothing. Softmax of w word. uc was nothing, but it was w context into x. और इसको आप लिख सकते हैं यूसी, ठीक है। तो हमें लॉस इज माइनस लॉग इन ऑफ वाई हैट, सो इज इक्वल टू माइनस लॉग इन ऑफ ई टू पावर डब्ल्यू समेशन ऑफ ई टू पावर डब्ल्यू 1 to v। ये तो हो गया। इसको हमें मैक्सिमाइज करना था बेसिकली, इस वाली वैल्यू को, बिकॉज वाई है क्या उस जगह पर है हमारा। तो इसको हमें मैक्सिमाइज करना है, और अगर इसको हम मैक्सिमाइज कर देंगे तो देन वी आर डूइंग द करेक्ट थिंग। फिर तो हमें लॉस की भी जरूरत यूज करने की जरूरत नहीं है। तो यहाँ पे क्या क्या लगाएंगे, देखेंगे क्या क्या है।
वैल्यूज कैलकुलेट नहीं करेंगे पहले पुट करके?
हाँ, वैल्यूज कैलकुलेट नहीं, वो सीधे फॉर्मूला ही पूछ रहा है। वो जो हम फॉर्मूला इन्होंने डिराइव किया था ना प्रोफेसर ने लेक्चर में,
बेसिकली ये इतना नहीं।
सो वो EWUC क्या
इस
है?
वीक के
ओके 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 ओके, फिर से देखो, फिर से
वीक 10 के नहीं देखे।
ये है, ये है, ये है, यहाँ पे ये वाली वैल्यू है जिसको मैं मैक्सिमाइज करते हैं, और इसमें इसने दे रखा है क्या क्या, ओहो ये भी मेरा, ये सीधे स्ट्रेट अवे है क्या? इट इज फ्रॉम दैट डेरिवेशन जो प्रोफेसर ने किया था उससे है। चलो
ठीक है, देन वील हैव टू चेक द लेक्चर अगेन।
ना सर, एक बार जैम बोर्ड में चलिए।
हाँ हाँ ठीक है, मैं बताता हूँ। ये देखो यहाँ पे फॉर एग्जांपल इफ वी टेक एज वी कॉन्टेक्स्ट, और इसको हम करते हैं वी डब्ल्यू फॉर एग्जांपल, ये है एच, एच इज इक्वल टू, ये है एक्स आपका, एच इज इक्वल टू वी सी इंटू एक्स, है ना, इसी को ये बोल रहे हैं यू सी। यहाँ पर जब ये आएगा तो ये हो जाएगा वी डब्ल्यू इंटू यू सी। ओके, इस पे हम सॉफ्ट मैक्स लगाते हैं, सो दिस विल बिकम ई टू पावर वी डब्ल्यू इंटू यू सी डिवाइडेड बाई summation of e to power v w hat into uc w hat is equal to 1 to v. This is the value of this है, ये जो मैंने कैलकुलेट किया यहाँ पर, बाकियों की चेंज होती रहेगी। Now what we have to do, we have to maximize this.
डिफरेंशिएट करेंगे।
हाँ
डिफरेंशिएट करना पड़ेगा।
क्या करना पड़ेगा?
मैक्सिमाइजेशन के लिए क्या डिफरेंशिएट करना पड़ेगा?
हाँ, डिफरेंशिएट करना पड़ेगा।
विद
तो इसको
रिस्पेक्ट टू
जब, हाँ, और अब क्या देखो, इसमें जो लॉस है, लॉस भी हमारा आ गया, लॉस इज माइनस लिविंग वाई हैट, और ये वाला अगर हम वाई हैट ले लेते हैं तो ये हो जाएगा माइनस एल एन ई टू पावर वी डब्ल्यू यू सी डिवाइडेड बाई ई टू पावर वी डब्ल्यू हैट यू सी 1 टू वी। जब लॉग लेंगे तो ये हो जाएगा लॉग न्यूमरेटर माइनस लॉग डिनोमिनेटर, हो जाएगा ना?
करेक्ट।
तो इसका ऊपर का जब लेंगे तो निकल आएगा माइनस वी डब्ल्यू इंटू यू सी, ठीक है? और ये माइनस माइनस यहाँ पे प्लस हो जाएगा, और ये हो जाएगा लॉग इन ऑफ
सम ऑफ
समेशन
समेशन
e टू पावर वी डब्ल्यू हैट इंटू यू सी, एंड दिस इज आई टू वी। और यही ऑप्शन दिया है आपका फर्स्ट के जो ऑप्शन है। मेरा बंद हो गया था गलती से, इसको मैं खोलता हूँ। इफ यू किसी के पास क्वेश्चन पेपर अगर ओपन है तो प्लीज चेक कर लीजिए, आई थिंक यही ऑप्शन है करेक्ट।
Yes, it is the correct option.
हाँ,
It's the correct option.
ठीक है। तो फॉर्मूला मतलब इसमें कोई वो नहीं है, स्ट्रेट अवे ये निकल के आ गया है।
बट ये फॉर्मूला लॉट का है ना, किस चीज का फॉर्मूला है?
ये फॉर्मूला नहीं है, बेसिकली दे आर जस्ट आस्किंग अवर कॉन्सेप्ट कि हमें जो अंडरस्टैंडिंग है वो हमारी क्लियर है नहीं है। तो हमारा क्लियर है कि भाई अगर हम एक हम वर्ड देते हैं और हमें पता है, हमें प्रिडिक्ट करना है कि इसके बाद में कौन सा वर्ड आना है, तो हम पूरी वोकैबुलरी में सारे जो वर्ड्स हैं उसकी प्रोबेबिलिटी ले रहे हैं, और जो आना चाहिए जो कि हमारे पास डाटा है उसको हम मैक्सिमाइज कर रहे हैं इस वाले को।
ठीक है।
तो इसको जो हमने लॉस किया, ये हमारा लॉस है। सो दिस लॉस है क्या, इसको जो डिराइव यहाँ पे लॉस हमने निकाला, तो इस वाली वैल्यू को हमें क्या, वी विल ट्राई टू,
लॉस को मिनिमाइज करने के लिए हमने डिफरेंशिएट किया,
हाँ
ऐसा कुछ। हाँ,
हाँ, लॉस हमने निकाल लिया है बेसिकली।
बेसिकली ये लॉस है ना, तो कोई हाँ बेसिक
हाँ, ये
क्वेश्चन
क्वेश्चन
क्या
क्या
था?
पूछ रहे हैं, आई जस्ट चेक क्वेश्चन। इसने क्वेश्चन पूछा था, चूज द एक्सप्रेशन दैट द मॉडल हैज टू मिनिमाइज।
ओके, लॉस मिनिमाइज
ठीक है।
करता है तो लॉस।
हाँ, तो ये लॉस है क्या हमारा जो हमने निकाला है, इस लॉस को मिनिमाइज करते हैं, है ना? तो दिस इज द एक्सप्रेशन व्हिच वी हैव टू मिनिमाइज। ये हमने स्ट्रेट अवे यहाँ पर हमने डाला है पूरा। माइनस वी डब्ल्यू इंटू यू सी प्लस लॉग समेशन ऑफ डब्ल्यू हैट बिलोंगिंग टू दिस एक्सप्रेशन वी डब्ल्यू हैट इंटू यू सी, वहां से निकल के आया ना। नेक्स्ट पर चले।
कितने क्वेश्चंस आएंगे इस पेपर के?
इसके लास्ट है,
कर लेते हैं।
हाँ। Now suppose we compute the gradients and update the representations with n is equal to 1. Choose the correct statement. Suppose the model predicts target word VW with probability score of 1, that is y hat W is equal to 1, then no elements in VW will get modified after one iteration. So that is true. क्यों true है? बिकॉज यहाँ पर आपका दिस वी डब्ल्यू कहाँ पर था हमारा, ये वर्ड है क्या यहाँ पर था। अगर इसकी प्रोबेबिलिटी 1 अगर हो जाती है, वही हमें चाहिए। सो आफ्टर दैट है वी विल नॉट अपडेट एनी इसको। क्यों कमलेश?
क्वालिटी 1 हो गया मतलब लॉस तो 0 ही होगा।
नहीं, लॉस 0 हो गया ना, तो उसके बाद हमारा कोई अपडेट नहीं लेंगे। सी वी नो कि आफ्टर सेट ऑन आना चाहिए, बाकी जो वर्ड्स हैं इसकी प्रोबेबिलिटी हमें घटानी है और इसकी प्रोबेबिलिटी हमें 1 करनी है। सो एज सून एज दिस बिकम्स 1 वी विल नॉट अपडेट, क्या our updates will stop. Second, suppose the model predicts target word VW with probability score of 1, that is y hat W is equal to 1, then no elements in VW hat will get modified after one iteration. That is also true. एक बार 1 हो गया तो उसके बाद क्या, we will just stop, we will not update के this, ये वाला जो बाकी जो वर्ड्स
बेस्ट सिचुएशन पहुंच गया था।
हाँ, बेस्ट सिचुएशन है कि वी वांट के 1 एंड इट हैज कम टू 1। मेरा सॉरी यार, मेरा लैपटॉप हैंग हो गया है। थर्ड वाला ऑप्शन कोई बताएगा प्लीज? हाँ, भी आ गया। ओके, थर्ड इज सपोज द मॉडल प्रिडिक्ट्स टारगेट वर्ड VW विद प्रोबेबिलिटी स्कोर ऑफ 0.5, दैट इज y hat W is equal to 0.5, then the elements of VW will be modified as VW is equal to VW plus 0.5 UC। ये मेरे सर के ऊपर से चला गया दोस्त, ये मैं आई विल कन्फेस आई हैव नॉट बीन एबल टू अंडरस्टैंड दिस थर्ड एंड फोर्थ। फर्स्ट एंड टू तो आई कुड अंडरस्टैंड। सो दिस if anyone understands we can discuss this tomorrow.
क्या थर्ड ऑप्शन था कि देखिए एक बार?
Third option, that suppose the model predicts target word VW with probability score of 0.5. ये बोल रहे हैं कि ये अभी 1 था, तब तक तो हमने अंडरस्टैंड कर लिया था। Now he is saying इसकी probability 0.5 हो गई। फॉर एग्जांपल ये 0.5 है, तो इनका बाकियों का भी सम 0.5 हो जाएगा।
करेक्ट।
सो ही इज सेइंग ये जो VW है, VW का जो अपडेट है विल बिकम VW माइनस लर्निंग रेट 1 है इसका, और he is saying VW is equal to VW plus 0.5 into UC transpose.
ये अपडेट रूल, जनरल अपडेट रूल कहाँ पे है, क्या है?
हाँ, ये 0.5 into UC transpose। अब ये तो हमें पता है कि ये जो VW है इसका जो डेरिवेशन लेंगे तो उसमें हमारा UC आ जाएगा, यहाँ पर UC आ जाएगा, दैट इज अंडरस्टूड। 0.5 क्या, दिस I have not been able to understand कि from where get this 0.5 is come.
Let's calculate delta VW, ना? I think it will give that.
हाँ, डेल्टा VW, चलो करें इसको, निकालते चलो। डेल्टा DW कैसे निकालेंगे? डेल्टा VW will become y minus, y hat minus y into UC transpose, ये होता है।
ओके।
नाउ y hat जो y है बाकी जगह में 0 0 0 0 है, ये 1 हो गया, ये 0 0 0 हो गया। ओके, ये कुछ भी वैल्यू होगी, इट डजंट मैटर।
ये 0.5 हो गया,
ये यहाँ पे 0.5 हो गया और यहाँ पे माइनस हो गया इनटू UC हो गया, VW हो जाएगा। अब इनकी जो वैल्यूज हैं इनकी भी सम में क्या होके आपकी
Yeah, it's correct, no? Like if for the 0.5 element,
0.5 into UC transpose हो गया है ना?
right, for the particular element.
Yeah, so therefore now VW is equal to VW प्लस हो जाएगा, है ना?
माइनस माइनस प्लस।
ऑप्शन क्या दिया इन्होंने? प्लस, ठीक है एकदम। थैंक यू, इट वाज सो इजी। Sometimes we just give up.
नहीं वो क्या क्वेश्चन पेपर के लास्ट में पहुंच गए ना तो फिर बोलता है छोड़ो यार.
ये बड़ा केस है. सही बात है ये.
Fatigue factor. Otherwise, it is so easy, na? When we apply our understanding. So at least I am happy कि at least concepts are clear, है ना? चलो let's see last also. Suppose the model predicts target word VW with probability score of 0.5. Then the elements of VW hat will be modified as this.
ये हमने जस्ट पिछला कैलकुलेट किया था ना.
तो ये जो VW का ये जो मैट्रिक्स है उसने बता दिया कि इसका जो पर्टिकुलर ये वाला जो एक कॉलम है वो तो इससे हो जाएगा और बाकी जो हैं किससे होंगे उसमें वो बोल रहे हैं कि इट विल बी VW हैट minus 0.5 UC3 transpose. YW है.
और ऑप्शन बढ़ाया.
हाँ.
Yeah, it's YW dash ना. Y cap W dash means the respective output, right? The respective output. YW dash.
Prediction.
Yes. ठीक है तो ये अपने YW हेड्स हो जाएंगे ना ये सारे YW1, YW2, Y head W3 ये सारे हो जाएंगे और इनको अपडेट करने के लिए यहाँ पर ये Y head W head UC ट्रांसपोज ये माइनस ठीक है. आई थिंक विद दिस क्या वी क्लोज दिस सेशन. सो आई थिंक वी हैव अंडरस्टूड एक तो दो हमें रिवाइज करने एक तो टॉवर वाला एंड सेकंड वी हैड टू रिवाइज व्हिच वन सेकंड वन एनीवन
डोवर वाला मींस
टावर
ओके.
एक तो टावर वाला रिवाइज करना था एंड वी हैड टू रिवाइज अनदर थिंग ना समथिंग व्हिच वी हैड मेंशन